Greetings, everybody. Peter Dyke, Executive Director of the Alliance for PE Pipe. Welcome back to the Alliance's webinar program, where today we kick off the season with a timely session on inclement weather, also known as cold weather. We certainly have it here in Virginia, and I'm sure we have it in many parts of the United States. So thank you for finding time from shoveling the walk or walking the dog on a route that you're not typically accustomed to, and joining us for this session. So joining me is my colleague, as usual, Alan Ambler. Alan, come on and say hello. Happy New Year.
Happy New Year to you. Glad to see everybody. I think Dan Landy says we only have about 3 or 4 days to say Happy New Year, but I'm going to be right there with you, Peter. I'm happy to welcome in 2026 in our webinar program for this year, bud.
Well, you've put together a fantastic slate of sessions, and what better way to start the season off than learning about polyethylene outfalls in the Arctic. I mean, what a great pre-show deck that was. We had over 200 people watching it. And, we have a lot to learn from people like Adrian Hanam. So good for you. Thanks for putting that together, Alan. All right, let's say thank you to all of the companies that help us fund our operations. We provide this webinar free of charge, but we can only do that because these many companies support our many events. Last year, we did 115 events, all kinds, shapes and sizes, and we have these companies to thank. All of these slides, we have somebody to thank. We've got a lot of industry experts that help us produce these events, and you got to take time to say thank you. So thank you to all these folks. All right, I'd like to bring on Tariq Spear. Tariq, come on and tell us a little bit about who you are and what you do. You're our featured speaker today.
Yeah, thanks for telling me. Hey, Peter, I really appreciate the opportunity to come back on with you guys. Super amazing people. Always enjoy the webinars and enjoy every chance and opportunity I get to chat with you guys and share my experience with our story on HDPE and kind of the evolution of why we ended up transitioning a lot of our standards to HDPE. Vice President of Operations for Fairbanks. Fairbanks is about 150 miles south of the Arctic Circle. So, we can see pretty much winter conditions from November to the end of May. And 24 years of experience with cold weather, utility operations, construction, design, management. And we installed our first HDPE project in 2012. And since then, I think we're up to about 21 miles of water main and 3 miles of sewer force main and probably 100 miles of services. So again, really appreciate the opportunity to join you.
Well, we learn a lot from folks like you. We appreciate you taking the time. Thank you, Tariq Spear. Carl Vrooge, please come on, tell us who you are and what you do, Carl.
Thanks, Peter. Carl Vrooge. I'm going to say Vrooge rhymes with Scrooge, Peter. You can remember that for next time.
Thank you.
Yeah. GF Eurocon. I'm based in Toronto. I've got 27 years of experience working closely with engineers, contractors, and utilities, focusing on freeze prevention of polyethylene piping. So I'm pretty familiar with the topic. And we it's a core business. We focus on cold weather installations all over the north, but into the middle region as well, where freezing might be an issue, right down to Texas.
Well, you've come to a lot of our road shows, particularly up in Canada, and we're so thankful for that. And we're thankful for your support as a valued member of the Alliance for PE Pipe. Thank you, Carl. We see you toward the end of the session. And now, finally, Chris Waite, back for another session with the Alliance for PE Pipe webinar program. Welcome, Chris.
Thanks, Peter. My name's Chris Waite. I'm with Secor. I'm the branch manager out of Gillette, Wyoming. Do a lot of cold weather fusion. Was just doing some this morning. As a matter of fact, it's not cold to Dan, but it's cold to us right now. So it's a pleasure to be here. If you got any questions, feel free to get in the Q&A and ask away.
Chris, come back on. You forgot that you're a sponsor today. You're helping us produce this. Thank you for your sponsorship.
Absolutely. I appreciate the opportunity to sponsor it. Good to see that we've got a good turnout. We're climbing right now. We're about 490 attendees minus the speakers.
Hey, tell us who Secor is and what you guys do.
Secor is an HDP company. We're based out of Houston, Texas. We've got 5 locations, Houston, Dallas, Albuquerque, Denver, and Gillette, Wyoming. Basically anything polyethylene, that's what we do.
Yeah, you're also a certified professional. You've taken that program with the Alliance for PE Pipe, and you're now a regular contributor to our podcasts, our webinars, and our trade shows. We thank you for that. Thank you, Chris Wade. All right, Alan Ambler, come on in and let's share these next few slides. Take it away, Alan.
Absolutely.
I'll go into the background here for a moment.
Okay, thank you very much, Peter. We're certainly happy to be here and happy to share all this information with you. But before we even start about cold weather, we got to tell you a little bit about polyethylene. So, what is polyethylene? It happens to be a semi-crystalline polymer and a thermoplastic. What does the thermoplastic part of it means? It means that you can repeatedly heat and cool and heat and cool and heat and cool this material, and that joint that we put together through that fusion process is as strong, if not stronger, than the pipe itself. It's made out of 2 particular regions that we have, the amorphous region and the semi-crystalline region. And what those mean is that semi-crystalline gives us the density, the strength that we need to be able to resist the pressure. That amorphous region holds everything together, but allows us to be rugged and durable and also flexible through that process. So that those 2 things work together and have been engineered into this product by many, many brilliant people with lots of different patents to be able to advance this process and grow the product in particular. So what are we looking at? What happens during our process? This is basically heat fusion illustrated. And what happens in the fusion process is we are taking those 2 sides together. We're pushing it up against a heater plate, melting that polyethylene at a molecular level down to a very specific temperature. Then we are pushing those 2 sides together and allowing those molecules to flow across that interface. And what that does for us is really joins all of those molecules. They're just hydrogen carbon atoms with a little bit of additives through that. Carbon black is one of them. And then we're allowing that to cool. And that cooling process makes it so that all of that fusion zone that we had is exactly polyethylene. The same thing happens at the extrusion facility, through butt fusion, through electrofusion, through any type of fusion. We're basically controlling the molecular flow across that interface. It's a really cool process, and it's very robust and stout and proven for a very long time. Isn't that right, Peter?
It is. And what we like to say is clean it, shave it, heat it, fuse it. So this is the shaving process. We use ASTM F2620 primarily as our standard, although some gas companies use different standards. But we put it in that McElroy fusion machine. We face or shave is another verb, means the same thing. We align the pipe ends, and then go to the next slide. After we've shaved it, Alan, then we put it in the heat soak process. We heat up those pipe ends so that those ends can fuse together like you just described. And all those little amorphous regions, they connect with one another. And that joint actually ends up being stronger than the pipe itself. So this process requires some training, Alan. We've got the 5 major companies there on the left that do the training. And then we also, Alan, have our distributors there on the right. They also do training. And people say, oh, it's more complicated than putting the bell and the spigot together. Well, it kind of is. You just got to be trained. But once you're trained, you get it. And all these companies get it. And they have training staffs, Alan.
Absolutely, Peter. That's the good part of it. Well, beyond the webinar, you can put your hands on everything, just like we would do at a road show itself there. So we'll train everybody, and then you can go to these companies here that help you train even more. So what is inclement weather here, Peter? What are we looking at?
So, yeah, we kind of use both phrases, cold weather webinar, inclement weather, but inclement weather is undesirable for outdoor events. And that's what it is. And we just don't want it to be cold weather. We want you to think in terms of all weather that's other than normal. So we've got precipitation, we've got wind, we've got cold, we've got heat, we've got fog. All of these things need to be taken into consideration. And then it can come, as I said there at the end there, go back one slide, please. It can come in many different forms. High wind, We want you to cap the pipe ends, extreme high temperatures. Alan and I were in Peru earlier this year. We were doing fusions. It was 95 degrees and very humid. All these things need to be taken into consideration. Another interesting thing, Alan, about this pipe is it can be full of water, it can freeze, and guess what? It's not going to crack. And here it is using some of Carl's insulated pipe. So here's water actually coming out of the pipe end that's been insulated without heat trace there. So that's about a 1-inch line and about a 4-inch overwrap. All right, Alan, take it away.
So we're looking at the temperature operating range. HDPE happens to be brittle at -130, which is very different than an amorphous polymer, which otherwise could be a PVC or products like that, which is brittle at 221 degrees Fahrenheit. So it is very ductile, very rugged and movable, and allows us to be able to work with it within our contractor pull base. So the contractors love this material because it is so rugged and durable through this process. We do need to look at thermal effects and thermal conditions. Basically, HDPE will contract in cold weather or expand in warm weather. And we will look at that dynamic change in temperature to be able to give us some idea as to whether or not that the extent to which that pipe will expand or contract in our area as well. So one interesting thing to note, that the expansion of the pipe is immaterial of the actual pipe diameter. So if we have a 200-foot pipe that has a 40-degree temperature change, we could see 8 inches that is expanding versus carbon steel at 3/5 of an inch. Now, what that gives us here is that coefficient of thermal expansion is larger for HDPE. That's not the end of the world, because once we translate that through the modulus of elasticity, which is lower for HDPE than it is for carbon steel, which is much higher, the amount of force required to restrain that 8 inches of growth is only 320 pounds versus carbon steel, which could be 4 tons to be able to stop it from moving that 3/5 of an inch. As we get into bigger pipe, that cross-sectional area gets bigger. And so now the force required to be able to restrain that also gets bigger as well. Isn't that right, Peter?
Yeah, I see a lot of people taking this issue, which I call a temporary condition, Alan, the thermal effects. These issues tend to be during construction. They are important during operation when we're above ground or at grade, certainly, but underground, these issues are not significant at all. This is one of my favorite slides here because it provides the engineer and the owner accountability. The data logger is an important tool that tracks hydraulic fusion, whether we're talking mechanical in the building and data centers, or we're talking a 30-mile pipeline that's going in ground. This data logger can track what the fusion tech did during the fusion process, and it can be reviewed by an inspector or an owner before that pipeline goes underground. Also, the side bend tester, you can cut out a coupon from a fusion, so it's a destructive test, and you can sample that coupon to see whether the fusion was done correctly.
One more half one. Good right there. All right, you'll release the pressure.
Okay, so now you pull that coupon out, and if there was a cut or a tear, it would have been a bad fusion. But in this case, there was no crack, there was no sound. This is a relatively inexpensive way to determine whether or not those fusions have been done correctly. So between the data logger and the side bend tester, you got it going. And then just make sure your fusion tech is properly trained. All right, bringing on Chris Waite from Secor, also our sponsor. Hey, Chris, Alan and I'll fade into the background now, and why don't you take over for a few slides?
All right. So the biggest thing to remember in cold weather operations or warm weather operations is safety. It's the number one priority when you're out there fusing. In the heat, it can get just as bad as it can in the cold. You can always put more clothes on, but you can't strip down out in the field. So remember that. Make sure that you're shielding your areas and capping your pipe ends and going from there in the wintertime and in the summertime if the wind's blowing. You need to maintain your equipment. The chart on here is really helpful for Macro. You get this off their website. It tells you the viscosity of oil and what temperature range you're operating in. Make sure you're running the correct oils in your machine on the hydraulic side, because it will affect fusion pressures, it will affect movement of the cylinders, and keeping everything running smoothly rather than chattering and moving too slow. If the oil gets too thick, the jaws have a tendency to move really slow until that oil gets up to temperature. There's a lot of tools out there. On the left-hand side, you'll see a poly porter from McElroy. That's good for 8-inch and down. They can also be used as dollies with a pair of them to move the pipe around on location if you're just doing a couple of sticks where you don't have to have as big of a piece of equipment out there. And then on the right side, you're going to see pipe rollers. There's a lot of different combinations of pipe rollers out there. I recommend using those, especially coming off your fusion machine. You get on the snow and ice, it's not so bad once you got your fusion cooled for the rough handling time. Then you can start dragging it on the snow and ice and it will not damage that pipe. Check your generators. Elevation is something that we run into up here that a lot of people don't. When you get down in the southern states and get close to sea level, that's where those generators are rated at the highest. Make sure that you got consistent power output. Check the amperage coming out. McElroy does put out on every one of their machines what the voltage requirements are for the heater and the fusion machine if it's an electric fusion machine, and make sure you have plenty of voltage there to run that machine, but also maintain your generators. Yes, Peter?
Chris, we get a lot of questions about welding generators being inconsistent power. For a lot of us out here don't really understand electricity. Can you explain why those welding generators aren't okay to run McElroy fusion equipment?
Yes, sir. So a welding generator is what is a square wave. So it idles up, it idles down. Even if you put it in full idle, it's still a square wave. And that abrupt drop in voltage will actually air out a McElroy heater, and it can cause you to burn capacitors out of an electric fusion machine, where a regular generator, like you see in the picture, is a round wave. So it transitions a lot better and doesn't short anything out. So that's the key to it, is making sure you have the right generator, but look at your elevation, because you need to make sure that as you go up in elevation, you're also going up in wattage, because you lose output out of that generator at higher elevations. You can go into ASTM F2620-24, and Annex A1 does have some cold weather procedures for every type of fusion, whether it's butt fusion, saddle fusion, or socket fusion. I recommend, if you are in cold weather areas, to get you a copy of ASTM F2620-24 and read through those cold weather procedures. MAB puts out a lot of good guidelines for fusing the cold weather. This is a free source. Go ahead, Peter.
Yeah, we get a lot of our content on for today, Chris, from ASTM F2620. The cold weather appendix was first published in 2020, and it was republished in 2024. And then also, as you say, this MAB guideline is fantastic. Thanks for bringing it up.
No problem. It is a free source, so you can get on the Municipal Advisory Board's website, or the website right at the bottom on plasticpipe.org, which is and go there, MAB08, and download a copy of that. It will help you tremendously in the field. Cold weather fusion, according to MAB08, the first thing you're going to do is remove snow and ice and melted ice from the pipe. That situation there you don't have to do the entire piece of pipe. Anything that's going to come into contact with a fusion machine, and I would recommend getting a couple feet outside of the fusion machine. This goes for I seen a question pop up earlier about dirt that's built up on the pipe. Same situation here. You need to clean that dirt off. Anything that's going to be close to the fusion zone, you need to clean off. That way it's not plugging up the serrations and the inserts of your fusion machine. You get gripping force, pipe's not going to slip. And make sure that all that's clean inside and out. There's nothing worse than getting ready to put the heater in. You bring it together and water comes running down the pipe because there was a little bit of ice in there, and the heat started to warm it up just enough where Now you've got water running down the pipe. So you have to stop. You have to clean that out. HDP does have a reduced impact resistance in cold weather. Don't drop your pipe. It's you need to handle the pipe just like anything else with care. I've seen people that just take a loader and shove a load of pipe off the truck, and that's really not a good situation there. So provide adequate enclosures for your pipe and your fusion tech. That's going to be one of the keys in the weather. I was just on a job the other day. The guys were out there and it was like 5 degrees and the wind was blowing 30 miles an hour and they didn't even have a tent set up over the fusion machine. And I said, guys, you got to stop. You got to get a tent over this and block the wind. And they were getting inconsistent fuses, and that will cause that. When that enclosure should be anywhere around 32 degrees, you should start enclosing it. And then space heaters will help. Preheat your pipe will help, and keep the heating tool and insulated container between the fusions. Patience is the key. This is the number one golden rule. Your cool down times are going to be your cool down times. Your heat up times in the winter time are going to be longer. If you're meeting a bead in the recommended time frame of ASTM F2620, which is 4.5 minutes per inch of wall thickness, you're probably heating under some sort of pressure. You have to be patient. Make sure you have no pressure and the beads are developing naturally up against the heater instead of with pressure. Golden rule number 2 is change the conditions, not the procedure. ASTM F2620 and MAB08 were written for a reason. Make sure that you're following that, even with their cold weather procedures. You need to change what you're doing on the conditions rather than changing the procedure. The procedure is set in stone on how you fuse pipe. Again, back to removing the snow and ice, the picture you can see there, anything that's going to come into contact with that fusion machine, and then about 2 foot outside of that is going to, it's going to need, that snow and ice is going to need to be cleaned off, scraped off with a plastic ice scraper. I don't recommend doing anything metallic on that pipe because you can scar it up that way. But remove the snow and ice inside and outside as far as you can reach on the inside without putting yourself in harm's way and crawling inside a piece of pipe. Obviously, the bigger pipe, you can do that. The smaller pipe, you cannot. But make sure you're blocking anything from running down, especially if you're fusing on a hillside. Examine your pipe. The car there, they had a bad day. I see a lot of people hit pipe, and when you get out in the field, that gouge in the middle, if it's not over 10%, go ahead, Peter.
Yeah. That's Richard Kloss has got a great story about a car hitting a pipe too, and the car was minus 30 degrees, and the damage, Chris, was at the bottom of the pipe. In this case, the damage was obvious. You know, we've got a tire in a car. Image number 2 is kind of interesting, Chris. You know, you look at that and say, "Oh, the pipe's damaged," but is it really?
No, and that's it. You can use a tire depth gauge. If it's not over 10% of the wall thickness, it's not considered derated. It's not considered damaged. You can drag it on the asphalt as long as you're not putting gouges in it that are over 10% of the wall thickness of the pipe.
Yeah, that's kind of interesting. Richard Kloss, you're up.
Yeah, just a quick comment on that. So if you do see those impacts, the one thing that we did not notice on that cold weather impact of the car, it did crack, but of course cracks in polyethylene don't propagate really long. They actually stop. So the crack was only about 1.5 feet long, but we ended up pulling that thing in through the drill because we did not see that crack because it kind of folds in on itself tight. And it was just make sure you inspect your pipe before you pull it underground, because it did leak. And the leak, of course, was right in the middle, right at the bottom, at the deepest point. So
yeah, Richard, you and I have been working together 15 years. That's the only story I've heard of where there was damage that was not seen right before a drill. I mean, how in your career, how many times has that happened?
yeah, that's the only time. But it was a bit of a bugger because we had 2 weeks to replace that line.
Got it. So Dan Landy and I were out on this job site in Arizona, and it was, gosh, Dan, I don't know, what was it, 15 degrees. And there was some JM Eagle pipe that had been damaged. And we're like, wow, what happened there? Well, they dropped it off of a front end loader. It was 36-inch DR17 and it cracked. So that does happen on occasion, doesn't it, Alan?
It certainly can. We had some questions about Arizona in particular for hot weather as well. So some of the things that you would look for in hot weather is to make sure that you understand the expansion through heating up of that surface as we go through, especially in temporary construction conditions when we're elongating the pipe and then putting it down into the ground and then allowing it to calibrate with the soil temperature as we go through there. So, of course, I'm derailing and going to talk about warm weather in that manner, but there are some places in Arizona with the cold weather that we're talking about as well. So we don't typically do a warm weather webinar, but there are some nuance through pressure testing in the morning as opposed to in the afternoon, because there's some expansion diametrically of that surface as we go through once we start to absorb the heat, which the carbon black does on the outside of the surface of the pipe there. So keep going, Chris. You're doing great.
Thank you. Don't drop your pipe. We've talked about this. As Peter just said, they dropped that stuff in Arizona and it broke. It can happen. Provide adequate enclosures. You don't want excessive heat in there. You want to get that pipe up. I try to get all my pipe up when I'm preheating and enclosures to around 50 degrees at a minimum. That can go either direction there. So you don't have to be exactly at 50 degrees, but that's where I feel the most comfortable making my fusions and preheating that pipe end. Protect your fusion area. You can see the tent down there. They've got the end of the machine sticking out so it can still pull fresh air in. You want to be sure that everything is going that way. You don't want to fill your enclosure with exhaust or anything like that. So be careful with that when you're just throwing a tent over a fusion machine, because these diesel powered machines they'll smoke you out eventually. On the right, you see Macroice Quick Camp. I have not had the pleasure of working with one of these yet. I don't plan on going to Canada anytime soon to really work with one, but it's a great machine. It's a Connex, folds out. It's got a fusion machine in there. You drag the pipe on through, make your fusions. Plug the ends of the pipe. This is a really critical situation. In the bottom left picture, you can see the blue plugs in the end of the pipe. Most of the gas distribution pipe that goes out to the field has those in it from the factory. Water pipe, we haven't adopted that. So make sure you're either taping a bag over the end, putting tape over the end. They make temporary plugs that you can put over the end. But shield that pipe that way, because it will funnel that wind up into your heater and drop your heater temperature where it's overworking your heater. Make sure your equipment's free of ice and snow. That goes to scraping the ice and snow off of there. Go ahead, Peter.
Hey, yeah, go back one slide, would you, Alan? I think this capping the pipe ends is really pretty important. Chris called it critical. In the lower left-hand corner, we see the manufactured polyethylene caps, which are great. But if you put those on in transport and there's a temperature change, they could pop out on you. So that's happened. The job site on the right, you've got basically duct taped synthetic over the end. This does two things: keeps the wind and the dirt out. Chris, it also keeps the animals out. I mean, how many stories have I heard about animals living in the pipe until it gets used?
There's a lot of it. I actually was pressure testing on a line that was not in the municipal water industry, and I was blowing the pressure test down, and I blew an animal out of the valve. So it was quite stinky when that happened, because it had obviously been in there for a while. So yeah, capping the pipe ends and bagging them off keeps the animals out of there, because that pipe, even in the cold weather, is going to still be warmer than being out in the snow and the ice.
Right. And then I like this slide a lot too, because here we have on the left, we have the guy doing fusion, and there's no snow on the pipe at all. And there we have a pipe stand over there, and it's fairly clean of snow and ice. So these are people that are taking the time and the care to do it correctly.
Yes, sir.
So, yeah. And then here, the one on the right, Chris, I just wanted to mention this one. This guy gets an F. I mean, the guy's got a tent, but he's got snow right up to the jaw. And as Chris, as you've described to me before, you got that heater going, that snow could melt and you could end up with water in the fusion zone.
It's not a matter of if that snow can melt, it's when that snow is going to melt. That heater's running 400 to 450 degrees. It don't take long for that heat to permeate out through that pipe. Hell, just the sun shining on it will melt the snow and ice a lot of times, especially if you get in a tent like that. So yeah, the F is really big there. It might even be an F minus. They should have cleaned that all the way outside of the fusion machine. It looks to me like that's a 1600, so they're fusing probably 54-inch pipe there, and there's a lot of snow and ice, so there's a lot of water there. If you were to melt that down, there's easily 3 or 4 gallons of water there probably.
Yeah, so Chris called it a 1600. So McElroy, with a lot of, particularly their larger machines, their primary name is in metric, not imperial. So 1600 millimeters, a 1.6 meter. So it's 1.6 times 39 is what the diameter that it does in inches. So you just kind of have to get conversant, particularly with the larger machines. And Chris, one of the things that, at ISCO they did on this one is they've got 6 different, looks like 412s. Why would they run so many machines, Chris, like that?
They just want to run it. They want to fuse a lot of pipe. And when you set it up like this, if you're fusing multiple different lines, the same operator can run. If you look at those machines, they're kind of turned. They appear to be turned around where one operator can run 2 machines. Your productivity goes up a lot by doing that, and having it all shielded that way with the white sheeting that they have keeps a lot of heat in there with running those machines, so you don't have to worry about it. You can just keep fusing and stagger your fuses where you can fuse a lot of pipe in a day.
Yeah, it's pretty exciting when you're doing long runs, what you can do if you have multiple machines. Okay, Chris, tell us about some heaters.
Portable heaters, you can use anything that's not going to put direct flame to the pipe. The salamander heaters at the top, we've used those. Obviously, you don't want to get them so close to the pipe that they start melting the plastic itself. Infrared heaters work great. We use a lot of heating blankets, especially in the electrofusion side of things, to preheat the pipe, put our electrofusion coupler on. Any of those are good options. Anything besides an open flame touching the pipe is a great option. I seen a question pop up earlier about somebody wanting to know if they could use a torch to melt the ice and snow out of the inside of the pipe. I don't recommend anything with an open flame getting that close to the plastic. Preheat your pipe ends. This is very imperative that you do that when you're pulling your pipe in and that pipe's sitting out there. In the new data logger app, it actually asks you for a pipe temperature, which is kind of nice. So it makes it real easy to pull that pipe up within about a half to a quarter of an inch of your pipe. You don't want to get it over 120 degrees, but just let it sit there with that heater in between, and it will preheat those pipe ends up. Yes, Peter?
Just to reinforce what you said, Chris, ASTM 2620-24 in the appendix tells us that preheating is preheating, but it's not preheat soaking. So you're not actually touching the pipe end. You're within to a quarter to a half inch at most. Is that correct?
Yes, sir.
Okay. So just want to make that very clear.
Use tents, tarps, and warm air. As you can see right there, they've got a flameless heater ducting it down through the pipe. You can, in a situation, if you don't set your heater properly, you can get that pipe quite hot. So you got to pay attention to what you're doing with it. But that's a great setup to be able to preheat 2 sticks of pipe at a time. They've got it mounted on the back of the truck. They just move it down when they're getting ready to make the next fuse and start preheating the next 2 sticks. So that's a great situation. Protect your heater. Make sure it's always in an insulated heater bag. There's a lot of different options out there that McElroy has. Every heater comes with a heater bag. So make sure your insulated bag part is not shredded, because that's another thing. As they start shredding, putting the heater in and out, they will start deteriorating, and you'll lose heat out of them that way. So just in a quick summary here, and Peter, feel free, don't drop your pipe, provide your adequate enclosures, use your tents, tarps, and warm air if possible, protect the fusion zone. That is one of the biggest ones right there. Making sure that there's no snow and ice in there. Portable space heaters are really handy for your operator. Preheating and keep the heating tool in the insulated container.
I might add, Chris, on that, keep the heating tool in that insulated container that McElroy gives us. You got to keep that container clean too, don't you?
Yes, sir. They've done a really good job now with putting webbing on the bottom, so the dirt actually falls out instead of having a sealed bottom on them, which is kind of nice.
Oh, I didn't know that. That's news. Chris, we just had a question come in, and I think it's a good time to reinforce it. It's important that these guys are trained, the fusion techs. You're an inspector. How do you know that the guy's been trained and he's just not feeding you a line on why is it he's going a lot faster today than he was yesterday?
Well, that's the biggest situation. You got to be sure you're getting trained by an adequate trainer. There's various distributors out there. McElroy University is great at their fusion training. They need to have a viable fusion certification from a viable instructor. With McElroy, I'm a McElroy certified instructor also. So I carry a card with me that I can just tap on their phone, and it pulls up a website from McElroy and shows that inspector my credentials that I'm a trainer. So make sure that your guys are getting trained by a viable trainer and not just a tailgate training. Fusion training should take a while. It shouldn't be just a 1 hour tailgate session. And that's what a lot of guys end up with out there.
Yeah, great point. All right, now the summary on heat. Let's take a look at that. Tell us about heat, Chris.
Yeah, so you need to understand the thermal effects of the pipe. The 110-100 rule is huge, both cold and heat. So it will expand or contract 1 inch per 100 or per 10 degree temperature change per 100 lineal feet. So as you're making these fusions and that pipe, when it's getting super hot, I was on a job where we had pipe temperatures of 156 degrees on the surface. It starts pushing on things. You have to make sure that you're shielding that area. The sun is key to block at that point. Again, protecting the fusion zone, putting your enclosure up. It could just be one of the little 10 by 10 tents from Walmart over it, but it's keeping the sun off the pipe and helping lower those surface temperatures. But one thing you really got to pay attention to is just because you took a pipe temperature at the top and it's 110 degrees, the bottom is going to be cooler than that. So you could see some inconsistent heating. I've seen contractors actually roll the pipe over and let it sit for a little bit until the temperature equalizes. Obviously, bigger sticks is hard to do that. Windy, same situation. Protect. That's what we got to do. We got to protect the ends. We got to protect the wind. I don't care if it's hot wind or if it's cold wind. We've got to protect the ends to keep the snow, the dirt, all of that from blowing up into the pipe, onto the heater, and into the fusion zone.
Yeah, just to close that loop, Alan showed that graphic, Chris, of the ends melting together during the heat soak. Imagine if you let the wind in and now you introduce contamination into that melding. You could end up with a weakened fusion joint. Have you ever seen that?
I actually have. There's a good day with no wind in Wyoming is about 30 miles an hour, it seems like. So it's protecting it is key. And you see a lot of guys out there that I'll throw a bag over the end, and you don't even got to tape the bag on the end. If you use like a burlap sack style, the synthetic ones, just put it over the end of the pipe and just keep that dirt and snow and ice and all of that from blowing up into the pipe.
Alan, Peter and Chris, we got a really good question about all of these things that are going on to be able to protect the fusion zone and teach people how to fuse. That seems to be leading to more costly than installing other products. And sometimes we get to really harp on some key things, and sometimes we don't. So I'm going to go right back to this particular slide. Thank you very much for that question out there. The productivity that we get by fusing multiple runs and long runs at one time really translates directly to major cost savings. When a contractor contractor understands that we can fuse out 500 feet, 1,000 feet, and then be able to dig a ditch for that long and dump that pipe right into it, then they're going to find that massive cost savings as we go through it. If we're just going to sit there and move the machine from one joint to the next, you're not going to do this efficiently. It is called a paradigm shift with our contractors to be able to understand that long linear length and our availability to be able to put this single piece of pipe that could be 1,000 feet into the ground is going to give us a huge amount of productivity. So that's part of the learning to train, learning that the joints are stronger than the actual pipe itself and fully restrained. And then we're going to move to this huge amount of productivity to be able to greatly further minimize that cost as we go through it. So thank you very much for being able to afford us the luxury of answering that question. And Peter, I don't know if you want to comment any more here, but we're ready to move on to the next one.
Yeah, Alan, one of the reasons we talk about polyethylene the way we do is, particularly post-COVID, pre-COVID, the off-the-shelf cost of polyethylene was more expensive than PVC. And for whatever reason, PVC has been more expensive ever since COVID. But we have seen in the 15 years I've been doing this, Alan, that polyethylene is consistently the lowest installed cost, whether it was pre-COVID or not, particularly when you're talking horizontal directional drilling or pipe bursting. But in many cases, our open cut costs up to 48 inches are less expensive. At 48 inches, we tend to be just as expensive as every other material because we're all open cut at that point. So Tariq, why don't you come on and your first question be, is polyethylene more or less expensive than legacy materials?
Less expensive.
Why?
Well, for one, cost, and my presentation is going to cover a lot of it, but shipping, like for Alaska and Fairbanks here, shipping is extremely expensive. And when you see one of my slides and you see probably, I don't know exactly, but I think we had a project where we had 36,000 feet of pipe we were putting in the ground, and it showed up in our staging laydown area on 2 trucks. I mean, any other material would come in rail cars, and super expensive. It's efficient, it's affordable, it affords you the ability to directional drill. Fairbanks, we have rivers on 3 sides of us, and we're continuously up against a river crossing, spanning it across a bridge, excavating it across during a winter freeze so that the ice will support the weight of the equipment and machinery. Reduces permit costs. I mean, when you can directional drill HDPE under a wetland, eliminate any of your surface permitting for that area. I'm going to kind of, I guess, start with my closing.
Yeah, please. Yeah, please start. We're a little bit behind because I've been talking too much. My apologies. Tariq, you're up. Tell us about Fairbanks.
Yeah, well, okay, Fairbanks, Alaska. I know everybody's experiencing a lot of cold across the Midwest, well, pretty much from Texas to Carolinas, but we kind of experience that every winter. And this winter has been exceptionally cold for us. So I think we hit a record. We were below zero for 32 days, which is the longest duration of that temperature in 108 years. And so while Fairbanks is beautiful in the winter, it's extremely cold and extremely harsh, or in the summer, can be extremely harsh in the winter. And so finding, materials that are affordable, efficient, reduce O&M costs, they improve the thermal heat retention of water that we're already paying hundreds of thousands of dollars to heat to keep our outer loops warm. Reduces energy costs, improves C factor, makes it cheaper and less costly for our ratepayers. I think our electrical costs here in Fairbanks I think they might have approached 30 cents per kilowatt. So yeah, Fairbanks Sewer and Water, we 5 MGD water treatment plant, 8 MGD wastewater treatment plant. Collections, distribution, about 250 miles of distribution main. Like I say, we said earlier, we have about 21 miles of HDPE. Now our standard for any expansion project is HDPE. Roughly 10,000 metered customers, and the temperatures do get cold. So this is our kind of headquarters, Utility Services of Alaska, with Golden Heart College Utilities, and the sign reading 41 below, and then off to the right, you see minus 50 below. So we track kind of through freezing days. Every winter, we can kind of track the ground depth, freeze depth in the ground, in the fields, and in the roads. This is an example of a road depth. It's kind of shaded, but this was in January 15th. Today's road depth was 8 feet, and you can see where the average is. So by end of April, our pipes and a lot of our infrastructure are sitting in 12 feet of frozen ground. In addition to just the seasonal freeze, we have a lot of permafrost. So Fairbanks, Arctic, we're 150 miles south of the Arctic Circle, very corrosive soils. Big plus with HDPE. We have permafrost, which just raises havoc on all of our infrastructure through these areas. As soon as you strip the surface and you excavate down 4.5, 5 feet, you put a pipeline in, and I don't care what you backfill with, that frozen ice is going to start melting. And this picture is an example of that. So some of the techniques we use for insulating, these next 3 slides are going to kind of show you what we have. This was a 8,500 foot long slip lining project with 14-inch HDPE SDR11 out by the airport. And we had just kind of came out of one of our slip line sleeves and aligned our pipe, installed a isolation valve, a fire hydrant, you can kind of see, and then we'll duct back in. But there's a local polyurethane contractor here that will come and they'll spray that pipe for us right in the ditch. So this is, I think, an 8-inch HDPE SDR 17. That same contractor built a 40-foot lathe, and they'll take the 40-foot lengths of HDPE and spin it on that lathe as they spray it. And so it puts a nice 2-inch uniform polyurethane spray over that HDPE before it installed. And I just want to give Chris a shout out. That was an amazing presentation, Chris. And I hope after this, you can tell me in some of these pictures maybe where we could do a little bit better. But as you see here, we have at least a heater. So, and this was that project. We did 36,000 feet, showed up on 2 truckloads. Again, probably product handling wasn't the best. However, the days were warm, and out of the 21 miles of HDPE, we have installed 3 miles sewer force main and hundreds of miles of HDPE water services. We have never, ever had an experience with a pipe failure, of fusion failure of any sort. And so we built a trailer for loading, transporting. This is an example of our laydown yard. Again, this kind of material here in Fairbanks would have came on rail cars. Just the cost of transporting it here would have possibly been enough to detour the benefit to the customers and rate base that it ultimately served.
Hey, Tariq, quickly, how do you ensure that you don't get failures? Do you have a training program? Do they all take the test? What's the deal?
Do. Yep. All of our operators are certified. So we are a licensed general contractor in addition to running a water treatment plant, wastewater treatment plant, and all other aspects of a utility. These guys are trained. They're certified. Our regulators, ADEC, Alaska, requires pressure tests. So we pressure test every pipeline to 200 PSI prior to putting it in service.
Got it. Thank you.
Yeah. Water quality here is horrible. lot of iron, manganese, arsenic, nitrates in areas. So for us, getting potable water to our area is kind of a priority for our utility. I mean, this is what comes out of someone's well. This one just kind of a tie-in, kind of goes into one of our projects and the benefits, cost savings. This project served 35 customers its first year. I think we have well over 100 connected since it was installed in 2013. So as our projects and experience with HDP evolved, we became better at thermal modeling our heat loss. It's kind of like a battle of BTUs. You have 40-degree water inside your pipeline, and you have in frozen ground 28-degree temperatures on the outside of it. And we discovered that if we're building a system and that system is 40,000 feet and that molecule of water takes 9 hours to get from point A to point B where it returns back to a transmission main, we can save hundreds of thousands of dollars on additional insulating by getting spools. We saved, I think, $600,000 in insulating costs and an additional $400,000 just in pipe fusing by going spools on this project. Go ahead. This was a repurposed U-liner trailer. We used to do pipelining, but we were able to mount the 4 and 6 inch spools onto this pipe trailer and then pull it through a McElroy pipe tamer. And this totally changed. I mean, you want to talk about cost savings. We were averaging 1,000 feet per day on this project, total project length. I think we directional drilled over 7,000 feet, had 2 river crossings, and averaged 1,000 feet per day. It was a really successful project.
So this is Richard Colossa's video that shows in sub-zero temperatures, that's a 5-inch DR9 line being uncoiled off that reel, and it's being anchored by that white pickup truck. That is not uncommon. Then on this next video, let's just sit back and listen to Chris Wade.
Through the series of rollers. This series of rollers will straighten your pipe. This series of rollers out here will re-round your pipe.
There's stored energy in this, correct?
Yes, sir.
So by the time that we take that pipe as it's manufactured and start to put it into this roll, now the process of the line tamer becomes we're straightening it out and we're removing some of that stored energy.
Yeah, that kinetic energy can really injure somebody if you're not careful. Because when you coil pipe, it has a tendency to make it oval as opposed to being 100% round.
I see that straightening out. Look at that puppy.
Absolutely.
You can get a wide shot of that straight.
Yeah,
No,
and
that's
we'll have the piece of equipment take the tension off the pipe, and you can see how it doesn't try to snap back. It just lays right down.
Absolutely.
So that even works, guys, with cold pipe. Now, that first image we showed, Tariq, that Richard Colossa video, they weren't using a line tamer, but you've used them with success.
We have, yeah, that project there too, and yeah, there is labor involved in pipe fusing, and but in my experience, the benefits for the cost, the handling, the ability to directional drill, to like a lot of our sections, we'll build them in 800-foot lengths, and then we'll put flanges on each side. And we'll have those all staged in a road right away or a easement, and our operators will start in the morning by excavating 800 feet of right-of-way road or easement, and then by afternoon they're pulling that 800-foot section over, dropping it in, putting a valve on each side or connecting to a valve installed the day before. And they're doing 800 feet per day on average. That's the insulated and jacketed. That's
crazy.
Uricon pipe with, we'll drag it 2 blocks or more from the staging area over to the project site. Just super efficient. I think project costs on our 4 to 6 inch are ranging from $45 to $65 a foot. And again, when we're able to pull the uninsulated, we're getting projects averaging 1,000 feet per day.
Yeah, that's impressive. Carl just told me that they pre-insulate flexible pipe and put it on coils. So that's cool. It's not just the straight polyethylene pipe. And as you described, Tariq, you've even dragged that on the ground. Take it away, Tariq.
So service line costs, about a third the cost for a customer to connect. A lot of our development areas and expansion areas, the properties are set, 300 feet back from the edge of the road or right away. So gets water from our main to the property quickly and efficiently. C factor I discussed, it's a battle of BTUs. So if I can run a smaller pipe, longer distance, provide the same GPM, the same service, I'm not having to pay near as much to heat that water, and I'm not losing BTUs over the time that water takes from getting from one point to the other, or our loops just circulate, and the only warm water that comes into a loop is through consumption. So again, running longer distance, smaller pipe, better circulation. Again, in addition to efficiency and affordability, everyone thinks price. And price, yeah, that is a benefit. But for our operations, I found over the years a reduction in O&M costs, reduction in heat expenses. I mean, we're paying, $300,000 to $600,000 a year to heat water to keep these outer loops thawed. Reduce that to it's running about $200,000 a year now. Reduced energy costs. This is an example of a service connection. You have the 3/4 inch HDPE supply return with a circ pump that'll circulate that water to and from the main to the property, and then 2 heat trace lines, thaw lines, a 1/2 inch BEX, just in the utmost chance it freezes, and then a trace wire all insulated in 3 inches of polyurethane. Yeah, so this was that slip lining project. A couple more pictures of it, and I think that pretty much wraps up my presentation, Peter.
Well, great job. So appreciate it, Tariq. Thanks for taking your time today. Please stay on and answer a couple more questions. But Tariq, so
guys.
great to hear from you. And now we welcome Carl. Scrooge rhymes with Scrooge. Take it away.
Yes,
Carl.
thank you, Peter. I'll motor through the slides given the time. Pre-insulated piping is our main solution for freeze prevention, and essentially it's 5 components. So it's core pipe, HDPE core pipe, whatever DR fits the job. It's generally a nominal thickness of 2 inches of foam and a jacket, and those 3 components are bonded together. The only other 2 additional components are heat tracing, if required, and insulation for kits and joints. So that's a picture of a finished pre-insulated pipe ready to roll off the line on the way to a job site. So it arrives at the job site ready to install. So here's an illustration of what the installation can do for you in terms of slowing down the time to freeze. And this is based on a no-flow condition at those temperatures. So for instance, an 8-inch pipe at a constant temperature of -30, a bare pipe's going to take about 12 hours to freeze solid. With 2 inches of polyurethane foam, it's about almost 9 days to freeze 100% solid to an ice cube. So the heavy lifting is done by the foam, the polyurethane foam. But still, the water in the piping can and will freeze if there's no flow over a long period of time. And so if required, we can add heat tracing to the mix and essentially provide basically a guarantee against freezing. And essentially the heat tracing works in behind the urethane foam, and in the event of a no flow, sort of pops on and keeps things nice and toasty. And we can design heat tracing systems that will run as far as 12,000 feet from one power plant. So pretty cool stuff on the heat tracing type. Essentially, the heat tracing runs through a conduit on the core pipe itself, as you can see in that picture right there. and it's run from a controller. So the controller monitors the not the ambient temperatures, but rather the temperature on the pipe wall itself. And a big question we get all the time is, hey, doesn't heat tracing, bring in danger of melting plastic? And sure, it's a possibility, but we guard against that with basically monitoring the temperature of the cable itself. So we've got a high limit or a safety factor built in. So even if someone goofed up and put the wrong voltage on a system that's supposed to be 110 and hooked up 240, let's say, this high limit will basically shut things down before it's a problem. So all good. Most common pre-insulated piping application is municipal water. As Tarek was explaining earlier, shallow bury. So the whole thing about shallow bury pre-insulated pipe is that you're saving money in installation if the frost zone is, especially if it's rocky and difficult to get under the frost zone. So it's a savings to be in the active frost zone with pre-insulated piping, with or without heat tracing. Next slide. So the heat tracing, bridge crossings is another very common application for pre-insulated HDPE pipe. One big benefit beyond the obvious advantages of polyethylene piping is that with bridge crossings, often space is an issue, and there's not a lot of it. Unlike with other piping materials like PVC or ductile iron, where you have to mechanically restrain the joint, which creates a bump or a change in OD, polyethylene offers a constant OD across the joint, so it keeps things nice and tight, which is desirable, especially in bridges. So there's a good picture of a large diameter HDPE pipe job running over a bridge. Very, very common. Mining. So we see a lot of polyethylene pipe and pre-insulated poly pipe in the mining sector, and in many cases, and in the north where mines are far away from population density, they basically will run the pipe straight on grade. So we take advantage of the flexibility of the poly pipe. And remember, in this case, the jacketing is a polyethylene jacketing. So it's pretty resilient stuff. It can be dragged into place. And even during service, it's moving around, but can handle that constant movement because of the toughness of it. And you can see the flexibility in that picture on the left as well. Intakes are a big one, outfalls, camps, things like that. So again, pre-insulated HDPE piping used to run either long distances or even short distances in terms of camps. Prior to a mine being established, they'll set up a camp and will run the water waste through pre-insulated poly pipe. And here's a good example of an alternate to a pre-insulated pipe. This is what we call pure split tube, and basically it's a 20-foot long section of polyurethane hinged and super quick to install. So Tarek was mentioning flexible piping. Well, there's flexible pre-insulated piping and coil, but you're limited to about 4 inches. So this would be an alternative solution for a coiled pipe that goes to up to 14 inches, although it's kind of hard to find, but this is a good example. FAQ. So we see the same questions come up all the time. So I already answered the first one. What do we do at joints and fittings? Essentially, at the end of a 40 or 50 foot long HDPE pipe, we cut back the insulation by 9 inches to allow proper fusion of the core pipe itself. And everything runs the same as a standard McElroy machine. It's just that the boys have to make sure that there's enough space so that the jacketing can fit through the machine, and we adjust the arms to allow for that. Standard lengths, as I mentioned, 40 or 50s. Shallow bury insulated pipe need H20 loading, and the answer to that question is yes. Urethane foam has a very impressive property, so it takes a lot of. We can basically install it even in the active frost zone against H20 loading at 1 or 2 foot bury. And minimum bend radius, this is a big question that comes up all the time, especially in the mining sector. The answer to this question is It's the same as standard poly. So we take the same rules. So as an example, DR11 is 25 times the OD. We just adjust that math to take the OD of the jacketing to get the minimum bed radius of pre-insulated piping with polyethylene jacketing. And how do we decide whether we need heat tracing? So we offer a calculator online for free that will basically jam out a number of hours before freezing. So it's a heat loss calculation based on worst case scenario temperatures and no flow. And then based with that data and intelligence, you can decide whether you need heat tracing or not. And we can kind of help you along with that. Largest diameter, we go from 1 inch to 48 inch.
Peter, sorry
Yeah.
to interrupt, but Carl, just want to verify the tubing that's used for the heat tracer is just a metal tubing, correct?
Not metal. It's plastic. Usually, it's PVC, but flexible as long with the polyethylene pipe. Or there's no channel at all. Good question, Richard. Sometimes it's just a space in the foam to allow the passage of a cable, and the cable is installed after the pipe is put in the ground or above ground.
And the cable's insulated.
Well, the cable, cable's insulated. It's got a slippery Teflon jacket. Correct.
So that's why you don't necessarily need a conduit once the tracer wire is put in.
That's correct. Yeah.
Awesome. Well, Carl, great job. Always nice to hear about your products. So impressive that you can do that. Chris Wade, your talents are fantastic. And Tariq, thanks for sharing what's going on and one of the extreme conditions that we see in the provinces and the states. So appreciate it.